Hello viewers, welcome back to my channel. In today's video, we will cover two main topics. First, we will talk about getting started in R and some of the basic syntax that you are going to be using as you do your programming in R. Then we will turn our attention to the different kinds of data objects in R and get introduced to a few of those. We will learn how to access different kinds of data objects and how to build them. R is very case sensitive. So coming from our SAS environment, that's something difficult to adjust with. Now, in our R Studio environment, which is a development environment for working in R, it is divided in four panels or panes. The topmost panel, the top leftmost is your source panel, and that's where you are going to develop code and you will be able to save it. The console panel is below the source panel. That's the window where you can execute interactive commands in R. That's also where your log information will appear. So as you are running code in your source panel, the result of when running logging information will appear in the console panel. Your environment pane that's going to be similar to your Explorer tab in SAS and will show you all the objects that you have created in your session. In the files panels, that's where you can see your working directory. You can see all the files that are in your working directory. That's where you can see all the packages that has been installed, and you will be able to tell which one has been already loaded in your session. If you see here, you can see some of the tick marks that these are the preloaded packages when we have opened these R sessions. Then we have the help tab where you can go and search for any topics which you want, and in the help search here and get to know more about it. So now let's start and check how we can start working with R. The first most important thing which we will be discussing in R is the operator, that is the assignment operator. If you see, we have the arrow. It's similar to an arrow which is directing towards the left sign, and it can be created using the less than sign and the dash sign, or if you want to use a shortcut for it, you can use alt and the dash sign. It will appear this operator sign. So now let's understand how the assignment is done in R. If we are reading from left to right, we can say that the object X is assigned the value of 3 into 4. And then whatever appears on the right side, that is here, the 3 into 4 is appearing on the right side of the assignment operator, will go, the value of this thing which we have mentioned on the right side will go to the variable or the object we have defined on the right side of this assignment operator. So in this scenario, we are assigning X as the result of 3 into 4, and a numeric value of 12 will be stored in X. Now, there are several ways to run a code in the source panel. If I click on a single statement here and then click the run button, here I'm on the line number 2 here, and if I run this, it will run in my console, and you can see that this statement has run. And in the environment panel, you can see that a object has been created with, by the name of X, and a value of 12 is stored in that particular variable or the object. So that is one way. Or the other way is that I can select the complete text here, and then I run it. Then also it will appear like this. In the RStudio environment, we do not have a block comment, but we can use a toggle, and we can use the shortcut of Control Shift C to comment out any of the text which we want to uh, add a comment, or comment out any line of the code which we have. So right now, if I want to say comment out this line of code, I can do as using a shortcut of Control Shift C. It this hash will be show as in the starting of the line, and this means that this line has been commented out. And again, if I want to uncomment the line which I have just done, I have to select that, and I can just again press the Control Shift C, and it will be uncommented again. So this is a shortcut which you can use to create any comment line in your R program. Otherwise, you can definitely write a hash, and then whatever comment you want to add, it will go as the comment here. For example, the first line of this code is commented out, and it's just mentioned that I am discussing the assignment operator after this comment. Now let's understand and see how we can create few other random objects in R. Right now, what I am doing is I'm creating 3 objects by the name of section A, section B, and section C, and I'm passing a random value to these 3 variables, these 3 objects. So here I'm passing the value of 20 to section A, and value of 22 to section B, 25 to section C. What I'm doing here is I'm saying that in section A, there are 20 students, in section B, there are 22, and section C as 25. And now I'm creating another object by the name of total students. And what I am doing is I am just adding all these 3 created the objects which I have created. I'm adding these 3 objects to create a new object by the name of total students. So let's run this 3 statements first and see what happens. Now, as you know that I can run these 3 individually right now by keeping my cursor on each line separately, or what I can do is I can select the code, the section of code which I want to run in one go. Right now, I'm selecting the 3 lines where I'm creating these 3 sections, and I will just run, and you will see that in my console, it is showing that these 3 objects are created. And in my environment pane, you can see that the object section A, B, C are created and also are showing their respective values. Now, as we have talked that R is a very sensitive environment. So what I am here is testing is that when I'm trying to do the summation of section A, B, and C students to create a variable or an object by the name of total students, I'm intentionally giving a wrong name here. Please note that the section C which we have created is having the C as in small letters, whereas when I'm creating the total students, I have intentionally mentioned a object name where the section C is having the C in capital letters. So let's see what will happen if I run this statement. So right now I am testing the another way of running the code, which is that I'm keeping my cursor on the line which I want to run, and I will just click on the run button. So now you can see that there is an error coming in the console that the object C, section C was not found. That is why, because what we have created in this session was by the name of section C, where the C was in small letters. And for R, section with a capital C is an object which does not exist. So that's the reason we are having an error coming in the console when we try to run this particular line of code. Now, after we have corrected this line of code and are giving the correct name, that is the section with the small c, and if we run this, we will see that total students, a new object by the name of total students is being created, and the value of it is the summation of all the three sections which we have given earlier. So in this way, we can create a new object in R. Now let's discuss if we want to see the values of any objects which we have created, we have created or is present in our R session, and if we want to know what are the values for those. So what we can do is we can just write the name of that particular object and run this statement, and in console you will see the value of that object. So right now, as we have created a section A with the value of 20, when I'm running this statement where I'm just mentioning the object name and clicking on runs button, I'm getting in console that section A is having a value of 20. Similarly, if I run on for section B and C as well, let's do all together. Here you can see section A, B, and C all together are showing as 20, 22, and 23 individual individual lines of statements, because we have given these three as three new statements. And similarly, if I want to display for total students also, it will give me a value of total students in my console window. So in this way, we can create some new objects in R. Now let's move forward and let's try to see how we can create, or rather I will say how we can read the data set in R and work on that data set. So first of all, the important thing to note here is that before reading any data set or any data from an external file, we will have to have their respective packages installed in our R. So right now, since I'm going to read a data set that is the ADA in our SAS format, in the SAS data set, I have to install the library or install the package Haven for this, because Haven is the package which will have the function for read underscore SAS, which will be used to read the SAS dataset. Again, please note that I have already installed the package Haven in my R in the earlier times when I was using R for my personal use. So I'm not going to install it again, but I'm going to load this Haven package in this session. So if you are working on R and reading the SAS dataset for the first time and you have not installed the Haven package, then what you can do is you can write the install.packages and in brackets, in parentheses, Haven in your console window, and just enter the statement. And what it will do is that it will take 1 or 2 minutes for console that to install this package. And once it is done, you can just write the library statement, which is like this, that library in brackets, the Heaven package, which I have installed. I am just uh, calling that package and reloading it in my current SAS, in my current R session, and it will get loaded. So right now I will load this, and you can see that I have loaded my Haven package in my current R session, and now I will be reading my SAS dataset. So while reading the SAS dataset, please note there are few things. Right now, what I have done is that I'm creating a data frame. We have the data sets in SAS, whereas in R we have data frames. So right now, on my left hand side, I am giving a name to that data frame. And since I'm going to read the ADA data set, so I am using the same name, that is the ADA name for the data frame, which I'm going to create while reading these SAS data sets. And after that, I have used the assignment operator, and then I'm using the read underscore SAS function here. And this function will take one information inside, and it will be in the parentheses, and it will have the path from where I have to where the file of my Adam ADA dataset in SAS format is played. So I am providing the path along with the file name and its extension. So here again, another point to note here is while reading the SAS file, I have to give the extension as .sas 7b dat as well, along with the path in the read underscore SAS function. So when I'm reading it, I let's run this and see what happens. You can see in console that this statement has run without any issues, and you can see in my environment panel, you can see that we have ADA data frame being created, and in this data frame, you can see that I have 1191 observation with 55 variables. So this is the way you can read the SAS dataset inside the R. Now, there are few functions which we can use to extract information about the data frame structures. For example, right now, the first, if we want to know the number of rows, although right now from the environment pane, you can see that there are 1191 observation with 5 variables, but if we still want to know the number of rows or number of columns in the data frame which we have created, we can use the function of n row or n column along with the name of the data frame which we have created. So the function n row along with, in brackets, the data frame name will give the number of rows in my ADA data frame here. So let's run this and see what happens. Now, if you see the console window, in the console window, after running this n row, I can see it is giving the value of 1191, which is same as the observations in my data frame. So this will give, the n row will give the number of rows, and similarly, the n col will give the information of number of columns, which is same as the number of variables here. Now let's see this function as well, and you can see the DIM, which is dimension, short for the dimensions of your data frame. What it will do is it will give you the rows and columns information in one go. So here, if I want to know the rows and columns in one go, I can call the function of dim and in brackets ADA, and you can see I'm getting the rows and then columns. So first it will give the rows, and then it will give the number of columns all here. If we want to get the column names, then we have to call the function of names here. Here you can see it will list down all the names of the columns which are in my ADA dataset. And the next function is, if we want to view the dataset, then you can write the view ADA in your script pane, and you can see the ADA dataset or the data frame has been opened here, and you can see all the columns and data as you can see in your SAS dataset. So this is the way we can see the data and other data structure frames. If we want to see the data set, we do not need to always write the view and the data set name. We can directly open from the environment pane as well. So here you can see on double clicking the environment pane, I can open the data set as well. Now let's understand some other important objects in R. The first one we will be discussing is the vectors. Vectors are another kind of data objects in the R environment. Data frames are usually made up of vectors. So those columns that we see when we are looking at a data frame, those are referred to as vectors. You can pull out a single vector from a data and extract a vector by using a specific construct when you provide the name of the data frame, the $ symbol, and then the name of the individual column or the vector that you want to extract. You can extract the entire column from a particular data frame or just the selected values. Right now here, what I am doing here is that from my ADA data frame, which we have just loaded in our environment, I am reading the column A term, and I am creating a vector by the name of my A terms here. So what I am doing in this statement is that I'm reading all the values which are there in my A term of your ADA data frame in my A terms vector. So if I run this, you can see that my A term vector is being created, and if you can see this in the environment panel, it is giving that this is a character vector, and it is having a value of it has the values of 1191 values here, and if you scroll you will see all the values also. So I'm not going to do that right now because it's a long list right now. So but however, if you want to get all the variables all the values of the variable in the data frame, you can write in this way. Or if you want to select only few of the values from the data frame in the column, then what you can do is you can write in the square brackets, you can write, if you want to say for example extract the first 5 values, then what you can do is you can write first, then the colon and 5. So what it will do is it will read only the first 5 values from the ADA data frame from the A term, and will create a vector which I'm giving the name here as my A term 5 to the vector here. So if I run this, you can see another vector is created by the name of A term 5, and it only has the 5 values, and it is of character time, and similarly it is having also giving the information about which 5 values will be there. Another way to create a vector is by using the combine function, which is the letter C along with the parentheses and the values which we want to combine. So if we do not want to extract a vector from a particular data frame, and instead we want to create our own vector, this is the way we can do that. Right now, I'm creating a vector by the name of A, and I am passing the values of numeric values to this vector A, which are just random numbers, for example, 4, 3, 6, and 5. So I'm passing 4 numeric values, and since we are having 4 values, so we will be using the combine function here, which is the letter C, and in brackets we will give the values which we want to assigned to this particular vector. So the A vector will have the values 4, 3, 6, 5 created. So here you can see when I'm running the statement for my A vector, in the environment pane, you can see a vector by the name of A is created, and it's of numeric character, numeric data type, and it is having 4 values, which is 4, 3, 6, and 5. Similarly, if I want to create a character vector, then what I have to do is I have to pass the character values in my parentheses separated by comma, and we can create here like this as I'm creating the values for my vector B. If I run this again, a new vector by the name of B is created, which is of character data type and have the value of ABCD here in its this vector is having 5 values, which is ABCDE. Similarly, if I want to create a Boolean vector, and if you know that Boolean is only having the values of true and false, and I want to pass a list of true and false to a vector, a Boolean vector, I can do in this way again, that I'm creating a vector of by the name of D, and again I'm using the combine function C, and inside the combine function I'm just giving a random list of the Boolean values, that is true and false, and I'm creating the vector. So if I run this statement, again notice that here the data type of this vector which I have created, which is the character D, vector D, is it is mentioned as logical vectors here, and it is having values of true, false, and true, false, true, and false. So here you will see that we are not in uh, passing the values true and false as in quotes, but just these specific values here when we are creating the Boolean vector. Another way of creating the vector is that if we have uh, to use some other functions, like if we want to create a vector which is having a value of from 1 to 10, then what we can do is we can just mention a vector name and the assignment operator, and then we can just mention the starting and the uh, ending value of that list from which we want to create. So right now, if I want to create a vector by the name of X, which should have the values of 1 to 10, then what I can do is I will write 1 and then colon 10. And if I run, you will see the vector X is created, which is of integer values, and it is having the values of 1 to 10. Similarly, if you want to create a vector which is having numeric values, but you do not want to increment it by 1, but you want to increment by a different incremental value, then what you can do is you can use a sequence function, and you can start mention inside the sequence function where what is your starting point and what is your ending value and what is your incremental value. So here inside my sequence, I am mentioning from equals to 0, and the end should be mentioned as 2 equals to 5, and it should be incremented by 5. So if I run this, my Y vector is created, which is of data type numeric, and it is having values 11 values, and if you will see that it is starting from 0 and it is getting incremented by 0.5, and it will go till 5 here. And another point to note between X and Y is that Y is numeric data type, whereas X is integer data type. In SAS, we have only 2 data types, numeric and character, whereas in SAS, you can see we are having different data types here as well, which is integer, numeric, float, and characters also. So you can see the values which are decimal values are considered as numeric values, whereas which are the integer values will have the data type as integers. Similarly, we have another function which we can use which is the value of REP, which is that if we want to uh, repeat the values, a particular value for a vector, that we can use a function that is REP, and inside this function we will mention which value we want to repeat and how many times we want to repeat. So right now I'm creating a vector by the name of Z, and it will have a value of apple repeated 3 times. So see, you can see that vector Z is created and the data type of this vector is character and the apple value is being repeated 3 times. So in this way, you can create a vector in R. The next concept which we will be discussing today is the factors. Factors are a special type of data objects, and we use this specifically with our categorical data, where we know in advance that we have a set amount or a set list of values that are in that particular vector. We can create a factor by running the factor function, and we run that against a particular vector. So now let's break down this a little bit. So right now I have a vector. I'm creating a vector by the name of sex, and I am passing uh, 9 different values to this vector, and I'm using the function combine to combine these 9 values in my vector by the name of sex. So what I'm doing is I'm passing in a random order, which is the values of M and F and U, which are male, female, and unknown. So I am creating a vector by the name of X. So let's create the vector sex first. So here the vector is created and it's of character type, and it is having nine values, and these are the values it is having in this particular order as well. Now using the factor function, I'm converting this vector uh, and creating a factor by the name of sex f. So if you see, if let's run this factor statement and see what happens. Now here in the environment pane, you can see we are having a sexf object, which is a factor, and you can see it's a factor and which is having 3 levels. That is, uh, what it will show in environment pane is that the factor which we have created, how many level values are there and what are the values it is having. So if you will see that we have passed 3 distinct values, male, female, and unknown, it is giving that the sex f is a factor with 3 level values, which and those values are f, m, and u. Please note these values will be in the alphabetical order. It will not be the order in which we have created the vector. If you notice the first value which we have passed in the vector was m, then f and u, but when the sex f factor is being created, it will have the information displayed that it is having these 3 distinct values, and it will be in the alphabetical order. And the next numeric values which you can see 2, 1, and 3, these are the values which will give the order in the numeric format. We will discuss this in further in this video in short time. So now let's see what this table function is. This table function is a summary function, and it will give the summary of our sex f factor. Let's see what it gives and how to interpret that data. So let's run this statement. And if in the console window, you can see that when I'm running the table function and passing the factor sex f, what it is giving is that inside this xf, I am having these 3 distinct values. It is giving me 3 distinct values, which are f, m, and u. And in the next line, it is giving how many f's, how many m's, or how many u's are there in my sex f factor. So here we had 3 females, 3 males, and 3 unknowns. So what I am getting is 333 for all these 3 values. But you have to note that the values, the f, m, u are in the alphabetical order and not in the order which I have used while creating my vector sex. So what now, if we want to display the values in the order which in a particular order and not in the alphabetical order, what we can do is that when we are creating the sexf factor using the factor function, we can pass two additional arguments, that is the level equals to and the labels equals to. So right now, again, I'm creating the sex f factor using the factor state function and passing the sex as my vector. But along with it, I am mentioning the levels and the labels. So levels is the argument which you will pass, and in this argument you will pass the order in which you want the values to appear. So initially it was appearing in my alphabetical order, but I do not want the sex f factor to have the values in alphabetical order, but I want to have the values like first M, then F, then U. So what I have done is that using the argument levels equals to I am, and using the combine function C, I am telling R that consider the M value as the first level, F as the second level, and U as the third level. And using the label statement, what I am doing is I'm giving a label to these levels. Right now, if you see, when we ran the table function on our factor xf, it just gave the value information, that is the F, M, and U. But if we want to display the label here and not the value, we can use the labels equals to function argument here inside the factor function, and we have to provide the labels of the order in which we are the, similar to the order which we have used in our label. So for M, we are passing the label as male. For F, we are passing the label as female. And for U, we are passing the label as unknown. So in this way, you can define the levels as well as labels for the values of the vectors while creating the factor. So let's run and see what changes. So now I have created, again created the factor sex f, and you will see in my environment pane earlier, which was showing that the levels was M and FM and U. Now it is showing the values of male, female, and it will show the third one unknown here. But let's see in details using the table function, which will give the summary of the factor, and see what this console says. So if you will see here, the table summary is now giving the values of the factor xf in the order which we want, that is male first, female, and unknown. And another thing is that it is using the labels and not the values which we have passed in the vector. So in this way, you can create the factors. We will explore about factors and vectors in greater details while we are working on further assignments in R in future. So right now, it's just a brief introduction on how you can create the factors and vectors. The next and the last topic for today's video will be how to create a data frame. So far, what we have done is we have read the ADA dataset, the SAS dataset inside our R, and created a data frame. But if we want to create a data frame from our own inside the R, how we can create it? So what we can do is to create the data frame in the R environment, we can use the data.frame function, and inside that function, we can pass the vectors which will become the columns of that data frame, and the values which these vectors are having will become the rows of the data frame. Let's see how it will work. Let's say, for example, we are creating a vector by the name of visit, and it is having 5 values combined together by the function C here, and these values are week 0, week 2, week 4, week 8, and week 12. Another vector we are creating by the name of placebo, and we are passing some random five numeric values again combined with the function C. And similarly, we are again creating a drug A, drug B uh, in the similar format what we have done for visit and placebo. Drug A and drug B are of the numeric format same as the placebo. One important point to note here is that when we are creating the vectors, and if we are going to use this vector inside a data frame, the number of values which we have passed in these vectors should be same. What does that mean is that, for example, for visit, we have passed five values, not the distinct, but five values here. So when we are creating the placebo vector, drug A or drug B, all these vectors should have five values only. It cannot have less than five, it cannot have more than five values. And another point here, if you notice here that for drug B, the fourth value is Na. So you might have a confusion that drug B being a numeric vector, how can a Na value be a valid value for this particular vector? So in R, Na is considered as a blank or a null value. So what we are doing here is that when we are creating a vector drug B, we are telling R that the first value is 10.1, the second value is 15.3, the third is 20.0, but the fourth value is a null value. And then we are passing the 21.1 as our fifth value. So in total, we are passing five values for drug B, which is in sync with all the three other vectors which we have created here. And the Na will be considered as a valid null value for this particular vector. So let's create these vectors first. I'm selecting all the four statements all together and running. And you can see that my drug A, drug B, placebo is created, and in below the visit is also created. Let's clear this environment first. I'm creating these vectors again because I have just cleared the environment. So now you can see that all these the four vectors are there, and their five values are also being shown here in the environment pane. So now if I want to create a data frame, say by the name of df1, I can use the function data.frame, and I can pass inside the vectors and in the order in which I want the columns to be created in the data frame df1. So if I run this, I'm right now, my cursor is on line number 84, but it will be considered as a single statement. And if I run this, my complete data frame statement is run, and my data frame df1 is created, and it has five observations for four variables. Let's open this and see what is the values. So you can see here that the vectors which we have passed uh, been has been converted as columns, and the values for those vectors is coming as rows in my data frame which we have created. And you can notice another thing is that the order of the vectors which we have passed while creating the data frame is also the order of the variables which is created in this data frame. So in this way, you can create a data frame. Right now, this is I will say, a longer method to create a data frame, but the same data frame can be created using a single step creation. And what we can do is that instead of just calling the vectors which we have created earlier inside the data frame, we can directly create our vectors inside our data frame here. So what I have done is I'm again creating the data frame 1. Let's create data frame 2 to avoid any confusion. And what I'm doing is I'm calling the data.frame function here, and instead of passing the vectors which I have created earlier. I'm creating the vectors here. So what I am doing is that I'm creating the vector visit. I'm passing its value using the function C, and same as for placebo drug A and drug B. And I'm closing the data frame function here. And if I run this, I will have a data frame 2 created. Again, you can see the data frame 2 is created with same number of observation and same variables. And if you will open it, you can see it's the same as the data frame 1 here. But the difference is that what we have done in the second way is that we have created the data frame in single step, but in the first data frame was created after we have created the individual vectors and passed those vectors separately in the data frame. So this is a short uh, introduction on how to create the data frames, the vectors, or the vectors in the R. Further, a much more detailed use of these functionalities will be uh, explored in further videos on R. So that's all for today. I hope you like this video. Let me know in comments if you want me to cover any specific topic. Till then, thanks for watching.